Thanks very much, Argonaut, and thanks very much, Eliza. We appreciate the opportunity to talk here today. If you want maximum exposure, maximum exploration exposure to the McArthur Basin, go for Redbank copper. Redbank has 14,000 square kilometres of exploration ground between the Northern Territory Queensland border and the McArthur mine. You can see the other explorers and mines that are there. As a history lesson for some of you, the McArthur Basin was first traversed by Leichhardt in 1845. Following that, a prospector who walked off a station, who was a cook, discovered copper out at Redbank in 1916. Mount Isa was discovered in 1923. The McArthur mine, which was called HYC, Here's Your Chance, was discovered in 1955. And the Century deposit was discovered in 1989. Since then, there's been no other Tier 1 deposit discovered in the basin. Geoscience Australia spent 4 years and over $100 million of taxpayers' money trying to identify an area that had the next Tier 1 deposit. And one of the areas that they've highlighted, surprise, surprise, is an area between the McArthur mine and Mount Isa. When you look at the corporate snapshot and the share price graph is really a proxy for the heartbeat of the company. The company was suspended from trading when new management took over in mid-2019 and remained in suspension until 15th of September last year. We raised some money, we went out on the ground in mid-2020, in July 2020, we pegged all that ground you see there. We initially had 1,000 square kilometres of ground and we pegged all the rest of it as open ground. So we've got a little over 500 million shares on issue, market cap somewhere around 30 million, and our major shareholder is the Wiley Group. Briefly go through the board. Tony Kiernan is our chairman. I joined in August 2019 with Daryl Henthorne. Bruce Hooper, who's in the audience here, is going to be speaking before we break this afternoon, joined in December last year, and Dale Henderson has recently joined us. He's the COO of Pilbara Minerals. Our exploration team is led by Mike Cowan. Alan Ronk is one of our consulting geologists. Alan worked for Mark Creasy for 20 years, and John Beeson is well known to a lot of you, has consulted in the copper exploration space for many years. So there you see the extent of the ground between Century and the McArthur mine. The area has been very lightly explored over the years. It's actually quite remote, although it's getting less remote. If you want to drive from Mount Isa to Redbank, it takes you 6 hours. If you want to drive from Darwin to Redbank, it will take you 13 hours. It's 2 hours from Mount Isa in a charter flight and 4 hours from Darwin. We've got an exploration camp on site that we've refurbished, so we've had up to 20 people at site during this exploration season. So what I'm going to take you through in the next few minutes is what we've achieved in the last 6 months of exploration on the ground. Yep, click. That's better. All right, so earlier this year we commenced an airborne EM survey, and what you see in the central picture there is a part-completed airborne EM survey, a VTEM survey. What you see is part of a conductor that has been revealed, and you can see the strip in the middle that hasn't been surveyed. Off in the centre of that survey, you can see the existing breccia pipes that are identified. Let's see if I can just in through here. That's the existing breccia deposits just in there. And just in there. So there's a VTEM conductor about 5 kilometres off to the east. VTEM conductor that's been revealed 5 kilometres to the east of the known breccia pipe deposits there. So that's never been known about before. There's never been an airborne EM survey. What does that conductor represent? Well, I'll take you through that in the next couple of slides. We've also been completing soil sampling through here at 500 by 500 metre spacing. We did a lot of soil sampling in 2019. This year we've collected over 4,000 samples. So we've assayed them for half the periodic table. A geochemist that's analysed them at the end of last year gave a technical interpretation of them and said they'd all been completely snotted. I won't go into the chemistry of those, but what it's revealed is a big magmatic and hydrothermal system operating in this area beneath the surface. What we're trying to do is to narrow our search space down and determine the best location within this area to drill. And it looks like that conductor there is revealing a shale which is approximately 200 metres at depth, which also has a chargeability anomaly. Just by chance, we were intending to drill it before the end of the field season. On Tuesday last week, the Northern Territory started shutting down the whole Redbank area and put it into a lockdown. We flew our staff out on Wednesday morning, so we had a target here ready to drill as soon as we start in the dry season next year. There you see the completed survey, and it's a discrete high conductor. This is a VTEM late time channel. So we've done some initial modelling of this, and it models up at about 200 metres depth. We've got some drilling that's nearby off to the west, and that identifies a shale at about 200 metres. The shale in that drill hole has a few anomalies in it. It's actually got a little bit of copper, a little bit of zinc in it, nothing more than 0.3 zinc. But we think the target is further out to the east, underneath this. We've done some ground IP, some dipole-dipole IP. This shows the chargeability anomaly coincident with the conductor here from the VTEM. So we believe we've got a compelling drill target when we start next year. So there's the VTEM conductor that models at about 200 metres, and there's the chargeability anomaly from the ground IP that we've just completed. So the IP crew finished doing that about a week ago, and they departed site Wednesday last week. Where should I point this to get the best? Right, okay, got it. That's much better. All right, so how have we got here? How have we got to the end of the field season? One of the things we're trying to do with such a large area is to narrow down our search space. We're not about to just start at one end and move to the other. We need to figure out how to target and put the best drill hole in the best place as quickly as possible. So we went back to first principles and said, what data is available where we don't have to go out on the ground and collect it? There's actually a lot of oil and gas data in this district. And one of the things that's very interesting about the Redbank project, about the breccia pipes, is they contain hydrocarbons. When you look at the Century deposit, that's got hydrocarbons in it too. When you look at the MacArthur River mine, that's got hydrocarbons in it too. There's oil and gas in this basin. Now, one thing that copper explorers in sediment-hosted copper deposits look for is to try and understand why the copper drops out of the fluid. So to form a copper deposit, you've got to have a source of the copper. We believe that the source of the copper is in volcanic rocks, where salty water has stripped the copper out of the volcanic rocks, sent it to the bottom of the basin, and then somehow there's been a seismic event with microseismic event that's tapped a structure down to the bottom of that basin. You've had something heated up and it's pushed it up closer to the surface. Now, how are you going to get that copper out? What you need is you need something we call a reductant. You need to have a pH switch. That copper fluid is all oxidized and you need to drop the copper out chemically. You can also drop it out by dropping the temperature and pressure, but if you drop it out chemically, it'll drop out and it'll take all the copper out of the fluid. So some of the work we've been doing here is looking at the oil and gas industry and highlighting the major structures through there, the major structures that we think could bring copper closer to the surface. Just press it once.
Hold it.
Got it? Okay. So I just briefly want to go through what the ore bodies that we already have at site look like. They're breccia pipes. Breccia pipes are formed when you get focused overpressure in the rock that cracks it up. After the rock's been cracked up, fluid that has copper in it flows through that rock and it drops out. Drops out preferentially if it's got a chemical reaction in that cylinder that is the breccia pipe. So what we have at Redbank is just under 90,000 tonnes of contained copper running over 1% in these breccia pipes. Now you've seen from the previous presenters, that's not a world-class ore body. But what it shows is that there's a fluid that's flowed through those breccia pipes that contains high-grade copper. That copper, if you assay the whole rock, assays a bit over 1%, but the rock that contains the copper is the matrix, not the clasts, and that's less than 20% of the rock. So we've got really high-grade copper in that matrix material. Can we go to the next slide? Oh, thanks. So you can see there the schematics of two of those small breccia pipes. Each of them contain approximately 30,000 tonnes of contained copper. You can see the map to the right that shows where those breccia pipes are located. So the Sandy Flat deposit has a small open pit that was developed in 93, 94. Sandy Flat was actually discovered by Newmont Mining in 1970 under about 8 metres of sand cover, which is why it's called Sandy Flat. It was discovered using IP. Simple work. Bluff is exposed at surface. You can walk over the top of it. Let's go to the next slide. One of the surveys that we completed is magnetotellurics. What this shows you is that the stratigraphy, the rock layers are layer cake. They slightly dip at about 10 degrees to the north-northwest, but generally they behave themselves quite well. What we've also found out from doing this survey is that the Wallagrang Formation, which is about 100 metres depth there, is conductive. The holes that we've drilled in here show that we have redox boundaries and we have small amounts of copper outside of the breccia pipes. So there is copper travelling in fluid through this rock. Let's go to the next slide. So what have we completed? Airborne EM survey where we found a red hot drill target, a 5-kilometre large airborne EM conductor that we're going to target for drill testing next year. We believe that has identified a shale reductant 5 kilometres off to the east of the known breccia pipes. We've completed ground IP over those V10 conductors. We've continued to do regional soil sampling, and over the next couple of weeks we'll be reporting on soil sampling we've completed right out to the west of the Redbank project near the MacArthur mine. We've completed gravity magnetotelluric surveys. We've drilled a 700-metre stratigraphic hole with results that we're yet to report on. And as I said, we've completed a helicopter-borne survey close to the MacArthur mine, collecting stream sediment and soil samples in an area that has 0 tracks. Let's go to the next slide. All right, so we've been able to gather together a good group of people to explore. It's a very rare thing to get highly experienced people working in this area. We're in a region that has the potential to host Tier 1 base metal deposits. We've got a land holding that is absolutely ginormous. So from east to west, that tenement is about 250 kilometres. North to south, it's about 90 kilometres. And in the breccia pipes, we believe, with the grades 1–1.5%, that we've got copper fluids coursing through those rocks that are high grade. Let's go to the next slide. All right, this is the final slide, and if you look closely, this is the road near the Redbank project, and as you look into the hill there, there's a breccia pipe, unsampled. No one's gone around the back of that hill and had a look at it. You can see it from the road. There are multiple breccia pipes through this region that haven't yet been assessed by prospecting or sampling. So we're in a region that's got multiple breccia pipes in there that we don't clearly understand, but we know a number of them, at least 7, hold economic amounts of copper in those pipes. Thank you very much.